Okay, I'm looking at our CO2 Dragster blank, and I have it. I removed this is the plate I was looking at building. Right here, let me get it turned on again. There we go. And I had it sitting on top of the plate, but I actually moved the body because I wanted to give it as much room as possible. So let me zero this here. So this is a model and a model of material. And a couple things I was looking at was I kind of forget the length of this. I know it's 42 millimeters, but I'm running an inch right now. And typically we only go machining wise halfway, so I'm gonna just round this off to like 0.8 or so. We need about 1 inch of travel, and that machine can do 1.5 inches of travel, so we're okay with travel. So you got to be able to get halfway, and you need to get up here for clearance. So we'll call that 1 inch. And then you have how much distance do you have between the tool all the way up and clearing this, which is this right here. So if you have now we need a tool that has about 1 inch sticking out, just to go on the plus side. And according to the specs, it should be 2.9 clearance. So if an inch sticking out, that would be 1.88 between this plate and up here. So on this would be, let's see, 1 inch up. No, I'm sorry, 1.6. We'll round it up. We'll make it 1.8. 1.8 up. Yeah, so it should just make it. I actually had the plate I was going to make underneath, and that kind of shrunk up too much room. So we could take that plate off, put this on, and it would make it. It's really close. In this particular case, if you took the, let me close this one up, shut that off, and let me turn that origin off. The blanks are always the same size, give or take. And if I put a clamp on this side right here, and a clamp based on the inside of this, clamp to the table, that would definitely hold it. If you aligned it to the flat surface here, that would get you alignment. So as far as a quick setup to do one side. Then if you rotated it, I did the same thing. If you use this side as your datum, right, and you use the pin and mount, you could roughly align this well, just clamping like that. Then you could figure out how to make a fixture out of that. So it's doable. Okay. And it's got, according to that sheet, it says 10 inches of travel and 6 inches of travel. Now I saw a video and they said 8, but it says somewhere, due to continuing product improvements, machine dimensions are subject to change without notice. Okay. Well, hopefully it's in the 10-inch range. The total body was, I think, 11.9 long. yeah, 11.9, which is the 305 millimeters. But remember, we're never cutting the front. We're always short anyway. So to get this somewhere around here should be within the range of the machine, or whatever length you can get to. So we always want to say, like, you got to stay within like 9.5 inches of length. You can't exceed that because you're going to exceed the travel of the machine. All right. So what I think I'll do is I'm going to write this program. This is just one tool, and this I consider just a roughing program, but it would demonstrate this. And we'll get a quick setup, clamp, align, touch the tool off, and cut this in the machine. We could do this without any additional. We got these slots here, so we got enough slot and a clamp on the inside to demonstrate this part. So back on. There. So this is everything. All right. I still want to use the flat plate. So, but just take that on and off. I think we want to make it so we can put it on quickly and have it align quickly. So if we have some built-in some pins that you can align it to this, like this groove right here, that'll get your alignment done. And you got your T-nuts and bolts which hold it, but the pins got to fit this groove with just a little bit of play. And that's a quick alignment. And you don't have to do any indicating or high alignment here. Same thing with this system. I saw the Techno stuff. They had kind of similar stuff. We can make all this. So you can get the plate on, you can get your vise on. So I'm probably going to make the plate shorter. And I was looking at the travel. Personally, I'd have the plate come out the front a little bit, just in case you needed clamping out here. Because your travel limit is around here somewhere. If you needed to clamp something outside the boundary. So you just take the plate and just push it forward. So I probably have to put another row of holes. So, and you don't really need to get to the, let me take this off. You can't get back there. It's this is like an unused area. So this is going to be, now how big the table is versus how far the machine can go. That's always we always know that because the table's always bigger than travel. But usually it's in the middle. This bridge system kind of makes it like shifted to one side. So this is your limit of travel. So I would like to have clamping surface out here, just in case. And back here is kind of unusable. So you can make the plate shorter, like maybe, from here to there. Instead of making it really long, because this wouldn't really use this side. Or if you did smaller work, you wouldn't need such a big plate. Maybe you'll do that. We'll just do a small plate. Actually, it might be a better idea to do small plate. And if you needed an extra plate because you're doing a big part, you just slide in another plate. So if we made a, I don't know, a 8x8 plate, that would be good for plate work. Get it done quickly. You get plate vise. You can leave the vise over here. Slide the plate on, take the plate off, slide the vise back in. Yeah, you can do that. And then you go in CO2 Dragsters, take the plate off, and put on, hopefully we'll get a CO2 Dragster fixture that'll work in this. Alright, so this will be development. I don't know what that is. So, we could also do, if you're a Mastercam, you could also do this kind of visualization. So this would be good because this actually won't move the machine. I think they're working on that part to get a machine movement kind of demo. So right now we are in, oops, let me do simulate this. So right up here is simulate, hit play. There's a cutting motion. So we're usually doing simulate with all this, without the machine there. So you're imagining the machine is there. Yeah. So you're not going to get any collisions, stuff like that. So, but you could build in like recognizing some of these other things here and see if it collides. You can build in some rigid boundaries and say, does this fit? And you can demo it right in here, like make a cube. It's got to fit in this cube. If it doesn't, some of your settings are wrong. All right. So you can pre-test a lot of stuff before you get on the machine. All right, I'm going to wrap this up and talk to you guys later.